All right, so in this last problem that I uploaded about the limiting reactant, we solved for which one was the limiting reactant. But the next thing that we've been doing in our notes is we've been talking about the excess reactant. Okay, so the excess reactant is the other one. Okay, so if we were using 42 grams of the benzene, C6H6 right here, and we're adding it to 73 grams of bromine. And I told you that the bromine, we found that the bromine was our limiting reactant because it made the lower number of product, right? So if bromine is the limiting reactant, that means that your benzene, that C6H6 in this case, will be our excess. Okay, so let's talk about what that means. So the excess reactant is the one that is like left over. Excuse me. So say you put together, you have 42.1 grams of C6H6, and you're adding it to, let's change colors. You're adding it to, this is actually liquid because bromine's liquid, 73.0 grams of bromine, okay? And when you react this together, you are getting this solution of, you're getting C6H5Br, and then you're getting some HBr over here. All right, so the reason I didn't really draw the HBr is because we didn't choose to calculate for HBr. We chose to calculate for the C6H5Br. So I'm really just going to look at these and talk about them. So I want you to picture this with me. So imagine weighing out 41.1 grams of benzene and then weighing out, wrong color. And then weighing out 73 grams of bromine, and then adding them together, and you get this brand new product over here, okay? But we found that this 73 grams of bromine will only make 0.456 moles of the product. And we also found that this benzene can make 5397. Okay, so if, say this path right here had enough bromine, this is how much product you would get. But unfortunately, we didn't have enough bromine to make this, so we could not make the 0.5397. We only had enough bromine to make this 0.456 moles. So the question, first off, was which one's the limiting reactant? Well, bromine is clearly the limiting reactant because it makes the lower amount of product, okay? So it stops the production at 0.456 moles of product, okay? So our question is which one's excess? Well, if bromine is your limiting one, then that means that your benzene is in excess. So oftentimes the question that comes with this is how much? Okay, so like how much excess? This is also, we normally say how much of the excess, how much of your excess reactant was left over? Okay. So you have to figure out how much was left over. But if I give you, so say I put in 42.1 grams. That's how much I give you. Well, we used a certain amount of grams so that we could make this 0.456 moles using all of the bromine. So there was a certain amount of this 42.1 grams that got used to make this process, but also some of it was left over. So this right here is how much we used, how much actually reacted, okay? And we can solve for how much was left by subtracting those two. So let's talk about how to find this right here. How much of our reactant actually got used? Okay, so when we're doing this, I'm being really colorful today. When we're doing this, we are going to be kind of backtracking. So we know that from our from our reaction that we used enough benzene and all of this bromine to make 0.456 moles of the product. So we made 0.456 moles of C6H5Br, okay? We used all 73 grams of bromine, and we used some of the 42.1 grams of C6H6. Well, I want to know how much of that we used. So we are basically setting up a new problem. We're going to say our given is 0.456 moles of C6, why did I put a 6? C6H5Br, okay? Because that's how much we made. So we made this and we used some of the C6H6 to do it. So this is our given. And I'm looking for how much of that benzene that we actually used. So the goal is question mark. It has to be in grams because this up here is in grams. We have to be able to subtract it. So grams of C6H6. So we have now set up a brand new problem. So anytime we have a brand new problem, we are going to start with our given. So we're going to start with 0.456 moles C6H5Br, okay? And we're trying to get to grams of C6H6. So let's start our factor labeling. Because we're in moles of C6H5, we can go and use the balanced equation up here. We can use this equation and go from moles of one thing to moles of another by using those coefficients. And so the coefficients are just 1 to 1. So I'm going to say 1 C6H5Br comes from 1 mole of C6H6. So that gets rid of the mole of C6H5Br. So this right here was just a mole to mole conversion. Okay. Well, now that we're in now that we are in moles of C6H6, we have to look at what we're looking for. We're trying to get to grams. So let's go ahead and finish that out. So remember, this is like a mole, okay? So that means that I can put 1 mole here. And since I'm trying to get to grams, I'm just going to put the molar mass in this slot. And so we already solved for that up here. I'm just going to go look for it. Okay, we found 78 to be the molar mass. So that gets rid of mole of C6H6, and now I'm in grams of C6H6. And remember, this is how much was used. Okay, so let's do the math on that. That's going to be 0.456 times 78. And this is 35.6 grams. So now that we know how much we used, we can go and plug this back in. So we can plug, we can plug it back in right here. And we can solve for this, okay? So now instead of it just, we solve for this x. So let me put that in. Oh, wait. So it's 35.6. Oops. So now I'm going to say 42.1 minus 35.6. And I get 6.5 grams of C6H6 left over. That's how much is left. So to go to use all of the 73 grams of bromine, I had to use 35.6 grams of C6H6, okay? So I used 35.6 grams went to react with bromine to make this amount of product, okay? Well, down here, what wanted to come over here but ran out of bromine was that extra 6.5 grams, okay? So this is what was left over. This is leftover C6H6. So I hope that makes somewhat of sense. It's just really the same steps every time. So when it comes to limiting reactant, let's go ahead and do our steps. Okay. Step one of everything is to make sure your equation is balanced. Okay, make sure that's all good and set. Step two is to solve for the same unit of the same product. Okay, so what I mean by that is if you remember up here, we decided to solve for the C6H6. Where were we? Right here. Oop, no. Up here. We decided to solve for the C6H6 right here. And we also decided to keep it in moles every time. So both times we solved for moles of C6H5Br. We solved for moles of that. And so step two is just to take those two givens and solve for the same unit and the same compound. So that's what I mean down here. Solve for the same unit and the same compound, and you're going to using both, I think that's spelled that wrong, using both reactants, okay? So step three is going to be find what your limiting reactant is. So the lower amount of product came from the limiting reactant. Okay, so you're going to find the lower amount of product, and you're going to say that is telling me which one was the limiting reactant. So that's what we did right here, where we said compare the 0.5397 with the 0.456. So you are comparing these two numbers, and since 0.456 is lower, that's telling you that bromine is your limiting reactant, which is what we did right here. We decided that bromine was the limiting reactant. Okay, and then if you want to do, let's go ahead and talk about excess reactant as well. So excess reactant okay, your excess reactant is the other reactant, and so what you're going to do, step one, is to basically identify it, but that is done up here. Okay, so you're going to take the lower product amount and back calculate to solve for grams of excess. Okay, this right here is what we did right here. So we took the lower amount of product and we back calculated to find grams of excess. Okay, and this tells you how many grams we used. So then the second step is to figure out how much you have left. So you're going to take the given amount minus the used amount, and that will give you what's left. Okay, so that's what we solved for.